For some of you, the distance formula is secondhand and you already know how to do it. But for those of you who the distance formula has always eluded just a little bit, or need a refresher on it, or it's the first time you've seen it, this allows us to find the distance between 2 points. In the other parts of this lesson, we're looking for the direction of the change. But this isn't direction, this just cares about how far away something is. If I said the wall on the other side is 6 feet away from me, I'm not negative 6 feet away from the wall. Although if I went in a forward direction 6 feet, I would hit that wall. And if I went in a negative direction, it would put me 12 feet away from that wall. So direction and distance are very easy to confuse, but on this one, we're only worried about the distance. So I've gone ahead and put 2 points on the board. I have a point at negative 1, 7, and that would be this one. And I have a point at 3, 4, so over 3, up 4. I want to know the distance between these two, and that's going to be easy for us to calculate. But if I went ahead and drew a line between them, and once again, it's not going to be perfectly straight, but that's going to be the best I'm going to do here. I'm looking at this line, I'm saying, I want to know the distance of this line. Now, if this was a really easy one, like it was the distance between maybe this point and this point, we would be able to just look at it and say, oh, that's pretty easy. That's over 3, that's over none. It's a flat, straight line. I would say 3 minus 0 is 3, and that's a 3-unit line. But this one right here, there's no way to do that since it's got a slope to it, a slant to it. But I could look at it and say, well, how far over is this one? Well, this one is exactly how far? Well, that would be 1, 2, 3, 4 this direction. So if I went 4 this way and then up 3 this way, I would end up with this triangle. And this triangle, of course, once again, this is not perfect on my board, but this would have a distance of 4 here and 3 here. And this is a right triangle, so I could use one of our favorite formulas, Pythagorean theorem, and say my distance is going to be 3 squared plus 4 squared equals my distance squared. So I could say, well, therefore the root of 3 squared plus 4 squared will equal my distance. And that's going to be easy for us to figure out. 3 squared is 9, 4 squared is 16, 9 is 16, and I could say 25 equals, the root of 25 is d squared, and therefore d has to be 5. And that's great, that works, and allows us to graph this out and see it. But what if we just had a formula that would do this for us every time? Well, once again, remember that delta means change in, so really I'm saying the change in my x value is how far I'm going here, and my change in my y value is how far I'm going here, and I'm going to end up squaring them anyway, so it doesn't matter which one goes first. So I could rewrite this. Instead of saying that one, I would say my distance is going to equal the square root of my change in x plus squared plus my change in y squared. And this is getting a little messy here in my corner, but this is going to allow me to say, well, what was the change in x? Well, x went from this was my x1 and my my x1, y1. I'm going to go ahead and write that way. This was my my first point, my point 1 and my point 2. So if I looked at that and I said, well, how far is this? I could say my second x value, 3, minus a negative 1. Well, that's 4. So I'm going to end up with 4. Remember, it's still squared here. And then I say, well, what's my y values? And that's going to be 4 minus 3, which is going to be 4 minus 7, which is negative 3 squared. And once again, this is why it doesn't matter the direction, because I'm looking at this saying that's okay because that's going to be a negative 3 squared, and I'm going to end up with my distance equaling 4 squared, which is 16, 3 squared, which is 9, And then I say d equals the root of 25 and d equals 5. So this formula right here, my distance formula, allows me to avoid having to draw this all out, and I can take any 2 points and find the distance between them. So I'm going to leave this formula here, and I'm going to go ahead and erase around it. Now we'll just rewrite this. My distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Therefore, I can take any 2 points that I want, 2, 3, and 8, 6, and look at those and say, there's my 2 points, and I can start plugging them in right to this. D equals the square root. Once again, I'm going to look at this is my x1 and x2. Here's my y1 and my y2. So if I look at this and I say, well, what's my x2 value here? And I look at my x2 value and say 8, and I subtract from it my x1 value, and I'm going to write in there for that formula. My y2 value over here is going to be 6, so I can say 6 minus 3 squared. And when I do so, I'll say d equals 8 minus 2, which is 6. 6 squared is 36. 6 minus 3 is 3. 3 squared, which is 9. And then I add these up and I say, well, that's fine, that's pretty simple. Here we go, 36 and 9, and that's going to equal 45, and I don't have a good root of that. But once again, I don't want to leave this like this. If it's simplified, if it can be simplified, I remember that 9 times 5 is 45, so I can say this is 3 times 3 times 5, and my distance in simplified radical form would be 3 root 5.